Hi, this is last in the series of videos for work, power, energy, and in this video we talk about power. So power is defined as the work done, which is in joules, divided by the time taken. Work done by time taken, right? So assume that you're applying a force F, and it moves through a distance of s. So your work done is F into s, and divided by time is, let's say the time taken is t seconds, divided by t, that's equal to F into s by t, that's equal to F into average velocity, right? And it is joules per second. The SI unit is watts. So 1 watt is 1 joules per second, right? So this is important. The alternate unit for power is horsepower. 1 horsepower is 746 watts. So this is an alternative unit for power. So generally power equal to work done by time equal to force into V average. So to understand power, let's do a simple case study. Let's do 2 questions. So the first one is, let's assume you have a staircase and this building is about 50 meters and you have someone who is 50 kg who climbs 50 meters at in about 200 seconds, and someone else does the same thing, but he is 100 kilos and he takes 300 seconds. So the question is, who is a better athlete? And to get an indication of who is a better athlete, we can get that indication by finding out power. So here the work done by this person against gravity is equal to mg into h. That's equal to 50 into 10 into 50. That's 25,000 joules. So your power equal to work done by time, that's equal to 25,000 joules divided by 200 seconds, that is 125 watts. So in this case your work done is mg into h, that's equal to 100 into 10 into, oh sorry, this is not 500 meters, this is 50 meters, and that's equal to 1000 into 50, that's 50,000 joules. The power is work done by time, and that's equal to 50,000 divided by 300, that's equal to 166.7 watts. So this person has exerted more power, so he is a better athlete in some ways. The second question is, if you have a car or if you have a body and somebody is exerting a force of 200 Newton, somebody is pushing it, and this object is moving with a velocity of 2 meters per second. So the power exerted by the person equal to force into velocity. This is the instantaneous power. So velocity at that moment, right? And this is given by 200 into 200 Newton into 2 meters per second. That's equal to 400 watts. So this is how you can deal with problems with power.